Somewhere over the Pacific Ocean right now, water that should be spread out evenly across thousands of miles is instead piling up in one place. And the agencies whose entire job is watching that ocean are telling anyone paying attention that the pile is now the biggest one they've ever measured. Not the biggest in a decade, the biggest since record keeping began. And because of exactly how this Pacific Ocean pattern works, that distant, invisible buildup of warm water is about to reach directly into American lives this fall and winter in ways that have nothing to do with the ocean itself and everything to do with floods, droughts, and storms that haven't happened yet. Picture two different Americas, layered on top of each other, both about to exist at the same time over the next several months. In one version, this winter looks roughly like the last several. Some storms, some dry stretches, nothing that breaks from the recent pattern anyone's gotten used to. In the other version, a specific, well-documented mechanism already visible in real ocean data right now reshapes rainfall, drought, and storm risk across a huge stretch of the country, hard enough that emergency planners, insurers, and farmers who didn't see it coming end up scrambling to catch up. Only one of those two versions is actually supported by what the data is showing, and right now, most of the country is still planning around the wrong one. Here's the actual documented reality behind that. NOAA's Climate Prediction Center currently puts the odds at greater than 90% that the El Niño event developing in the Pacific becomes what's officially classified as a very strong event by the time this fall shifts into winter. That's not a guess buried in a long technical report. That's close to a full scientific consensus, this far in advance, which almost never happens with seasonal forecasting. And separately, pooling together the results of 26 independent computer models run by forecasting agencies around the world, 25 of them now agree this event will reach that same very strong classification, with 15 of those 26 actually projecting sea surface temperature anomalies so extreme they exceed the highest category the standard measurement scale was ever built to describe. To understand why any of this matters to someone who has never thought about ocean temperatures in their life, you have to understand what El Niño actually is, because it isn't some rare exotic event. It's a natural, recurring climate pattern that's been reshaping American weather for as long as anyone has been measuring it. El Niño is the warm phase of a cycle called the El Niño Southern Oscillation, driven by unusually warm water spreading across the central and eastern tropical Pacific. Under normal conditions, steady trade winds blow from east to west across that ocean, piling warm surface water up against Asia and Australia, while cooler water wells up along the coast of South America. El Niño happens when those winds weaken or reverse, letting that built-up reservoir of warm water slosh back eastward the way tilting a bathtub sends water rushing toward the opposite end. Once that warm water spreads out, it doesn't stay contained to the ocean. It reorganizes where the atmosphere generates rising and sinking air, which shifts the position of the jet streams that steer weather systems across the entire globe. That's the actual physical thread, connecting a patch of unusually warm equatorial water to what happens on the ground in Sacramento, in Miami, in Oklahoma, thousands of miles away from the ocean actually driving the change. Only 3 previous events in the modern record have ever crossed into genuine Super El Niño territory. 1982 into 1983, 1997 into 1998, and 2015 into 2016. Each one left a mark that scientists and disaster planners still reference by name today. The 1997 to 98 event alone caused somewhere between $35 and $45 billion in damage worldwide, driven substantially by catastrophic flooding across the Americas. This year's event isn't just on pace to join that list. Comparing this year's daily warming curve against the historical development of those 3 previous events shows it running measurably ahead of all of them at this same point in the calendar. Not 1997, which sat around 1.6 degrees Celsius above average at this stage. Not 2015, at roughly 1.3 degrees. This year is outrunning both, and because El Niño events almost always keep strengthening through fall before finally peaking between November and January, that early head start suggests considerably more intensification is still coming. Here's the detail that separates this event from every Super El Niño that came before it. And it's the specific reason disaster planners should be paying closer attention this time than in past cycles. This El Niño isn't developing in a climate system that resembles any of its 3 predecessors. Global average temperatures are already running more than 1.4 degrees Celsius above pre-industrial levels, a baseline that simply didn't exist in 1982, in 1997, or in 2015. Every previous Super El Niño formed against a comparatively cooler global backdrop. This one is stacking record ocean warmth directly on top of the warmest atmospheric baseline humanity has ever measured. Climate scientist Daniel Swain, who studies exactly this kind of compounding interaction, has put it about as plainly as a researcher typically allows in public commentary. We have never, in the entire era of modern climate measurement, experienced a strong or very strong El Niño arriving on top of a global baseline this warm. That's not a repeat of a familiar pattern. It's a genuinely new combination of conditions the modern climate system hasn't been tested against before, which means the historical playbooks built from 1997 and 2015 may meaningfully underestimate what this particular event is actually capable of producing on American soil. There's a technical wrinkle in how this event's strength is being measured that's worth understanding honestly, because it affects how confidently you can compare this year against the past. For decades, El Niño strength has been tracked using the Oceanic Nino Index, which measures how far Nino 3.4 sea surface temperatures sit above a fixed historical average. But because the whole ocean has already warmed due to the broader climate trend, some researchers argue that comparing raw temperatures against an old fixed baseline overstates how unusual any given year's warmth looks. A newer measurement, the Relative Oceanic Nino Index, instead compares the Nino 3.4 region's warmth to the rest of the tropical ocean at that same moment. Using the older raw index, this year is blowing every previous year on record out of the water for this point in the season. Using the more conservative relative index, it's running roughly neck and neck with 1997 for the strongest start ever measured. Either way, the conclusion holds. This is one of the 2 or 3 strongest starts to an El Niño event ever documented. So let's walk through, specifically, where and how that risk is expected to show up, because disaster isn't one single event here. It's a set of distinct, well-documented regional threats, each with its own mechanism, each worth understanding on its own terms. Start with California, because it carries the most historically dramatic El Niño precedent of anywhere in the country. A strong El Niño winter reliably shifts the Pacific jet stream southward, funneling additional moisture into a state that often runs comparatively dry the rest of the year. During the 1997 to 98 Super El Niño, that shift produced a sequence of atmospheric river storms, long, narrow bands of concentrated tropical moisture stretching thousands of miles across the Pacific, that triggered widespread, sometimes catastrophic flooding and landslides across the state. That's the specific disaster mechanism California needs to watch for this time. Not one big storm, but a repeated back-to-back sequence of them, arriving over ground that gets less able to absorb each additional round of rain the more consecutive storms hit it. It's worth being honest, though, that this signal isn't guaranteed. The 2015-16 Super El Niño, despite reaching genuinely historic strength out in the open Pacific, notably failed to deliver the wetter winter Southern California had specifically been bracing for. Even a record-strength event doesn't automatically translate into an identical outcome every single time. Next, the Southern Plains and the Gulf Coast, which face a different, more disorienting kind of risk, a genuine seasonal whiplash. This entire region has spent much of this year locked in persistent, punishing heat and drought. A strong El Niño winter typically flips that pattern, funneling wetter, cooler conditions into exactly the same corridor, arriving in this specific window when farmers would ordinarily be finalizing decisions about fall planting and harvest based on the opposite assumption. That flip carries real upside, meaningful drought relief for stressed reservoirs and agricultural land, but it also means infrastructure and planning built around one set of conditions suddenly has to adjust to the opposite, on a timeline measured in weeks rather than the months institutional planning usually requires. Then there's the risk that connects most directly back to disaster-scale consequences. Repeated rounds of heavy rain producing flash flooding, not from any single dramatic storm, but from the cumulative effect of a pattern that keeps producing rain over the same ground multiple times in a short stretch. When the first wave of rain soaks into soil, that soil has less capacity to absorb whatever follows a day or two later. Instead of soaking in, each additional round increasingly runs off the surface, overwhelming creeks, storm drains, and low-lying roads faster than the ground can handle. That's the specific mechanism behind a lot of the flood damage tied to previous El Niño winters, and it's exactly the kind of risk that tends to catch people off guard, because no single day in the sequence looks dramatic enough on its own to trigger real alarm. It's the accumulation that does the damage. And then there's the part of the country that connects to a story most people have already been living through without necessarily linking it to El Niño at all, the unusually quiet Atlantic hurricane season. A strong El Niño reliably increases wind shear across the tropical Atlantic. Winds at different altitudes, blowing in different directions or different speeds, strongly enough to tear apart developing tropical storms before they can organize. That's a direct, well-documented mechanical relationship, and it's the specific reason this year's hurricane season has produced so few storms, with long stretches of complete inactivity across the entire basin. But a suppressed season isn't a risk-free one, and this is worth stating plainly. It only takes one storm finding a gap in otherwise hostile conditions to produce a serious, damaging landfall, regardless of how quiet the overall season has looked. If anything, an extended quiet stretch can leave coastal communities less vigilant than they'd be during a more visibly active year, which is its own specific, underappreciated form of risk heading into the back half of the season. There's also a genuinely underappreciated dimension worth understanding, tied specifically to a phenomenon called rapid intensification, a tropical cyclone's wind speed increasing by 35 miles per hour or more within a single 24-hour period, dramatic enough to turn a modest tropical storm into a major hurricane before forecasters, let alone the public, have had much time to react. Research tracking the costliest tropical cyclones to hit the United States since 1980 has found that the overwhelming majority involved exactly this kind of sudden, dramatic strengthening at some point in their life cycle, and current research suggests that unusually warm ocean temperatures, which are running high across large stretches of the Atlantic and Caribbean this year, may be increasing how often storms undergo this kind of rapid escalation. That's precisely the mechanism that makes even a quiet hurricane season worth watching closely rather than dismissing. The danger was never really about how many storms form. It's about how quickly any single one of them could transform if it finds the right combination of warm water and favorable upper-level winds along its path. It's worth being genuinely careful here about where real confidence in this outlook actually ends, because overstating certainty erodes trust just as thoroughly as understating a genuine risk does. None of this is a guarantee of a specific, predetermined disaster in any specific location. Regional rainfall and temperature projections tied to any El Niño event, even one with this much model agreement behind it, still carry real uncertainty this far in advance. The 2015-16 event stands as direct, well-documented proof that even a record-strength El Niño in the open ocean can still fail to deliver one of its most historically reliable regional signals. What can be said with real, evidence-based confidence is narrower, but still genuinely significant. The underlying oceanic and atmospheric pattern currently building is developing faster and trending toward a higher potential peak than any El Niño event in the modern historical record, arriving on top of a global climate baseline warmer than during any of those previous events. A combination multiple climate scientists have specifically and publicly described as genuinely unprecedented. So, what does America's next weather disaster actually mean in practice? Once you move past the headline and into the specific practical stakes this event is raising, it means California's flood control infrastructure, reservoir management, and levee systems, built and operated around decades of drought-era assumptions, may need to pivot rapidly toward flood management posture if this winter's storm sequence materializes the way the strongest historical precedent suggests it could. It means agricultural planning across the southern plains faces a genuine whiplash scenario, flipping from persistent heat and drought into wetter, cooler conditions in the exact window that planting and harvest decisions get finalized. It means coastal communities along the Gulf and Southeast, coming off an unusually quiet hurricane season, need to resist the natural pull toward complacency that a quiet season understandably creates, because the atmospheric conditions capable of producing a single serious, fast-intensifying storm haven't actually disappeared, just because most of the season has been calm. And it means flood-prone communities anywhere in the path of this winter's likely storm track should be paying attention now, checking their own area's flood history and drainage situation before the rain actually arrives, rather than in the middle of it. There's one more practical dimension worth naming plainly, because it's the part most likely to actually catch someone off guard months before any of this becomes obvious on the ground. Insurance markets, municipal budgets, and household financial planning all tend to price risk based on recent familiar history, what last winter looked like, what the last few years have generally trended toward, rather than a fast-emerging signal still building in real time. That lag is normal and usually harmless in an ordinary year. In a year where multiple independent forecasting agencies are converging on a genuinely unprecedented combination of record ocean warmth and record atmospheric baseline warmth, that same normal lag becomes the specific mechanism by which entire communities end up caught off guard. Not because the information wasn't available, but because the systems people rely on to translate a seasonal forecast into practical personal preparation simply haven't caught up to a signal moving this fast. There's a broader, more human reason this particular event deserves more attention than it's currently getting, and it has less to do with the quality of the science and more to do with how attention naturally works during a slow-building story like this one. A hurricane approaching landfall in 72 hours generates an immediate visceral sense of urgency. A clear countdown, a clear map, a clear moment when the danger arrives. A gradually strengthening oceanic pattern built up over months, described using technical terms like sea surface temperature anomalies and effective wind shear, measured in fractions of a degree Celsius, simply doesn't generate that same visceral urgency, even when the underlying stakes, measured in dollars of potential damage and millions of people across multiple states affected, are considerably larger than any single storm. That's exactly why a story confirmed by NOAA, backed by 25 out of 26 independent forecasting models, and flagged by climate scientists using words like unprecedented, can still sit largely outside everyday public awareness until its effects actually start showing up as flooded streets, disrupted harvests, or a winter that catches an entire region off guard, specifically because nobody saw the underlying signal building months in advance. That's the real, honest, and genuinely useful takeaway sitting underneath this entire story. If you live anywhere within the regions historically sensitive to El Niño's influence, California and the broader Southwest, the Southern Plains now facing a real seasonal whiplash, the Gulf Coast and Southeast still inside an active hurricane season, or simply anywhere, planning around the assumption that this coming winter will look roughly average. This is a genuinely evidence-based moment to actually engage with your region's specific seasonal outlook, rather than letting this story blend into routine background noise. The ocean has already sent the signal. What happens with it now depends entirely on whether the people in its path start preparing before the pattern actually arrives, or after.